Prepare for an unfathomable disaster of extraordinary magnitude. Teetering at the edge of our system, the Red Goliath star carries ominous messages across the universe. Using the James Webb Space Telescope, cosmologists have discovered something remarkably fascinating about this massive celestial body. The serious confession of the famous astrophysicist Brian Cox raises the question: are we witnessing a catastrophic cosmic explosion that could forever change the night sky as we know it? We dive into the complex tapestry of the universe, where stars are born, live, and die in amazing ways. One star has recently captured the imagination and concern of cosmologists and the public alike. This star is Betelgeuse, a red supergiant of great size and age, prominently located in the constellation of Orion. Its unmistakable reddish hue and variable luster have been of interest for a long time. However, recent developments have increased interest in this celestial monster, suggesting that we may be on the verge of an amazing event in the life cycle of this star. Betelgeuse, about 1,700 times the size of our Sun, is a celestial behemoth. Its immensity is almost beyond human comprehension. Imagine a star so massive that if it were to replace our Sun, its surface would reach beyond the orbit of Mars and swallow Mercury, Venus, Earth, and Mars in its celestial embrace. This amazing size not only shows the physical characteristics of Betelgeuse, but also represents its stage in the life cycle of the star. As a red supergiant, Betelgeuse is in the twilight of its existence, a phase characterized by expansion and cooling after a lifetime spent fusing a hydrogen core into helium. Betelgeuse, believed to be approximately 8.8 to 8.5 million years old, is relatively young in human terms, but ancient in stellar lifetime. Its current status as a red supergiant is the culmination of millions of years of stellar evolution marked by dramatic changes and processes that turned it from a hot blue star into the red giant we see today. The life cycle of stars like Betelgeuse is a story of change driven by nuclear fusion and gravity. Betelgeuse's unmistakable pink hue is another sign of its current phase. The red color is due to its relatively cooler surface temperature than stars like our Sun. The surface temperature of the Sun is about 5,500 Kelvin, while the cooler surface of Betelgeuse registers a temperature of about 3,500 Kelvin and emits light at frequencies that give it a red appearance. The mystique of Betelgeuse is enhanced by its historical variability. Changes in Betelgeuse's apparent brightness and variability have fascinated stargazers and skygazers for centuries. Betelgeuse typically goes through a cycle of 400 days and a longer cycle of about 5 years. These cycles were recorded as early as 1836, perhaps even earlier in the original oral traditions. But what makes Betelgeuse truly puzzling is not only its variable brightness, but also its deviation. Unlike many stars that follow a predictable pattern, Betelgeuse occasionally deviates from a rhythmic dimming and brightening pattern that reveals complex and less understood processes within its epic structure. Recent groundbreaking discoveries have attracted the attention of cosmologists and astronomers worldwide due to the dramatic change in its appearance. In an event in late 2019, now widely known as the Great Dimension, Betelgeuse, one of the brightest stars in the night sky, mysteriously began to dim. The dimming of the star was so intense that it began to lose brightness by 0.01 magnitude per day, reaching its lowest brightness in February 2020. Betelgeuse, which is normally visible to the naked eye even in light-polluted areas, has dimmed considerably, obvious even to casual observers. But there is one problem with observing Betelgeuse activity: the time it takes for the light to reach us. About 725 light-years away, the light visible today left the star nearly 7 centuries ago. This lag makes it difficult to predict and observe sudden changes in a star's behavior because we are essentially looking at its past. The Betelgeuse dimming event served as a reminder of the inherent difficulties of astronomical observation and the limitations of our understanding when dealing with vast cosmic scales and timescales. Andrea Dupree, Associate Director of the Harvard-Smithsonian Center for Astrophysics, and her team closely followed the progress of Betelgeuse's celestial drama. They used Hubble to analyze the giant star as part of a 3-year study to track variations in Betelgeuse's outer environment. These observations provided unique insights into the dynamics of a variable star like Betelgeuse, which is constantly expanding and contracting, causing changes in brightness. Hubble's sensitivity to ultraviolet light allowed scientists to study the layers above the star's surface that were partially heated by the star's intense convection cells. Further studies of the Hubble spectra at various points in 2019 and 2020 measured the movement of material in Betelgeuse's outer atmosphere. The spectra focused on the magnesium-2 lines, which indicate the conditions of the star's atmosphere. These observations showed that material is moving from the surface of the star into the outer atmosphere at about 200,000 miles per hour. That hot, dense material eventually expanded thousands of kilometers from Betelgeuse and was the precursor to the dust cloud that caused the star to darken. Dupree and his team estimate that roughly twice as much material was lost from Betelgeuse's southern hemisphere during the 3 darkening months. This mass loss was significant, especially considering that, like all stars, Betelgeuse is constantly losing mass, albeit at a much faster rate than our Sun. The size of this massive explosion and the resulting diminution has led to a debate among cosmologists as to whether this event could be a precursor to a supernova explosion. The proximity of Betelgeuse, approximately 725 light-years from Earth, adds to the intrigue, as any such explosion would be visible from Earth and would provide a rare opportunity to observe a supernova up close. However, this question remains unanswered. What does this dimming event portend for the future of Betelgeuse? Is this a sign of an approaching supernova or just an exceptional episode in the long and complicated life of the star? Several hypotheses have been proposed to explain this sudden change. One prevailing hypothesis proposed a stage in the supernova process that gained traction when Betelgeuse was widely believed to be coming to an end. Another popular hypothesis involved dust, perhaps from the star itself, obscuring our view. Betelgeuse, like other red supergiants, can leak material, and that material is thought to form a dust cloud thick enough to drown out the star's light. A third explanation involved changes in the star's photosphere, or visible surface layer, that could affect its apparent brightness. Further studies using different observational methods solve this mystery. Spectroscopic studies showed a decrease in Betelgeuse's effective temperature, suggesting that the dimming may have been caused by a large dark spot on the star's surface. This hypothesis was supported by the observation that the temperature of Betelgeuse decreased by approximately 170 Kelvin at the moment of darkness, revealing massive changes on its surface. Finally, the key to understanding this strange phenomenon came from humanity's guardian of space, the Hubble Space Telescope. Hubble's observations indicated that the dimming of Betelgeuse was probably caused by a massive ejection of hot material into space. This material formed a dust cloud that obscured part of the star's surface, effectively reducing the amount of light reaching us from Betelgeuse. The dust cloud is thought to have formed from superheated plasma ejected from a large convection cell on the star's surface. As it passed through Betelgeuse's hot atmosphere into the cooler outer layers, it cooled and formed dust grains, creating a cloud that blocked light from about a quarter of the star's surface. Hubble's ultraviolet spectroscopic observations, which began in January 2019, were critical in charting the timeline leading up to Betelgeuse's dimming.
Those observations detected evidence of dense, heated material passing through the star's atmosphere in the months before it dimmed. In December 2019, several ground-based telescopes also observed the dimming of the star, especially in its southern hemisphere. This material, initially brighter than the star's normal luminosity, eventually led to a blocking shadow as it moved outward and cooled. It was assumed that this outflowing material and the resulting shadow caused the star to suddenly dim. The magnitude of this throw was truly remarkable and brought Betelgeuse into the cosmic spotlight. The star was ejected with a mass approximately 400 billion times the mass of a normal star explosion. This ejecta material, which is thought to weigh many times the weight of our moon, was an important event in Betelgeuse and our understanding of stellar mechanics. But how could such a massive material explosion affect Betelgeuse and supernova theories in general? The implications of supernova theories are significant. Conventional understanding assumes that red supergiants like Betelgeuse shed mass at a roughly constant rate before reaching the dangerous end of their lives. But the size of this ejection casts doubt on that idea, suggesting a more turbulent and perhaps more unstable end-of-life phase for these stars. At some point, Betelgeuse may be preparing for its grand finale, a supernova explosion. Recent research has speculated about the timing of such an event, suggesting that it could occur sooner than previously thought, perhaps only a few decades from now. The concept of spring shock is another important piece of the Betelgeuse puzzle.